we are going to learn how to calculate the modified internal rate of return. In our last session, we covered the internal rate of return. We saw how to the procedure on the determination or calculation of internal rate of return. So the modified internal rate of return is a variation of the internal rate of return. And why do we need to modify the internal rate of return? It's because the internal rate of return has a limitation. It has a weakness, which the MIRR modifies or corrects. The MIRR addresses a key limitation of the IRR. That's why we are referring to this technique as modified IRR. You understand? And the limitation of the IRR, the limitation in IRR, there is the assumption that reinvested cash flows earn the same rate of return as the project's IRR. That is to mean that IRR assumes a single rate of conversion of all future cash flows into the present value, and there is the implied assumption that internal reinvestments are taking place at the rate equal to the IRR. So I know at that point, candidates, that is Greek. Okay? I know I'm speaking Greek up to that point. I don't expect you to understand what I've said. So don't blame yourself if you don't understand what I've just said. There are things that are understood later. There are times you understand things later. When you look back, we call it hindsight. That is when you understand certain things. Okay? And our insight here is just calculation. When you get into the calculations, I know your minds are wired to understand calculations fast. Okay? So just have that at the back of your mind. That just understand that the modified internal rate of return is a variation of the internal rate of return. I know at least up to that point you understand the meaning of IRR. It is a variation of internal rate of return. We are modifying a key limitation of the IRR. So in order to overcome the limitation of the IRR, the modified internal rate of return has been developed. And there are only 3 stages, which I'll share before we do an illustration. Steps in calculation of IRR. Steps. Step number 1, determine terminal values. Terminal values. In calculating modified internal rate of return, step number 1, determine terminal values. Terminal values. What are terminal values? What are these terminal values? Now, terminal values are the values or the cash flows at the end of the project. Values at the end of the project. Values at the end of the project of all cash flows. And how do you determine terminal values? We use the cost of capital as the discounting rate. Values at the end of the project of all cash flows using the cost of capital as interest rate or as the discounting rate. Again, candidates, don't bother to even memorize what we are saying. Let's just move on. All right, let's move on. Step number 2 is to get the total terminal value. Or we can say total terminal value is taken as a single cash flow. Total terminal value. Total terminal value is taken as a single value. Total terminal value. Total, because we are getting the present value of year 1, then at the end of year 2, then at the end of year 3, you discount cash flows for year 4, then you get the total terminal value. You add addition. Okay, it's just addition. Adding. And you have calculators to do the addition. Okay. So the total terminal value is taken as a single cash flow. As a single cash flow is taken. This is as a single cash flow of the project. Now, there are just 3 steps. I guess there are 3. First, you determine the terminal cash flows each at the end of each year. Then you get the total. Then you take the initial investment, which you are also given in the question, and the terminal value as the only cash flow, and then calculate the IRR. Take the initial investment. Check the initial investment. This one you are given in the question directly. The initial investment. The initial capital. So you take the initial capital and the terminal value as the only cash flow. This is the terminal value determined in step number 2. And then calculate the IRR. That is the MIRR. So you only need two values. That is the terminal value and the initial investment. Initial investment. They are just two things. Then you have your IRR, MIRR, which is then modified. And later on you'll see it is just simple. We will take the nth root. To convert all this into a formula candidates, you just have the nth root. You have the terminal value divided by the initial investment minus 1. But you don't have to memorize the formula candidates, and that's what I don't want you to do. Let's get an illustration. Let's do an illustration. Suppose a firm expects the following cash flows from a project. Suppose a firm expects. Listen to that language. Expects. That means that the company is budgeting. We are the budgeting phase. Expects. This has not happened. So we use capital budgeting techniques to make decisions. So you are the finance manager or something, and there is a decision that has to be made as to whether to invest in this project or not. So the company has, or you have helped the company project the future cash flows from a project. The initial investment is 10 million. After the end of year 1, the company expects to have a cash flow of 5 million, year 2, 5 million, year 3, 5 million. Assuming the cost of capital is 10%, what will the modified internal rate of return? That is the question. That is the question. The cash flows are given. So how many years are here? 3 years. 3 years. Then we have another column for the cash flows. So there is year 1, year 2, year 3, cash flows 5 million. 5 million. 5 million. These are cash flows. So, step number 1, determine terminal cash flows. Determine terminal cash flows. That is the values at the end of the project of all cash flows using the cost of capital. In this question, the cost of capital is 10%. 10%. Do you see that? So we need to get the terminal cash flow. The rate you are given 10%. The rate is given there 10%. So candidates, the terminal cash flows, the 5 million will be received at the end of year 1. So what is the future value of this money? What is the value, the terminal value at the end? The terminal values at the end of the project of all cash flows. So this will be equal to this 5 million. We compound it. We compound. Compound means getting the future value of the cash flow. This 5 million will be received at the end of year 1. So meaning, by the end of year 3, what will be the period? We are going to compound these 5 million for how many periods? Compounding candidates means calculating the future value of a cash flow. And we know the formula from time value of money. We are now applying the time value of money techniques, candidates. If you are to get the future value of an amount, which is in present terms, we compound by multiplying this present value by this factor 1 plus r raised to n. So the future cash flow is the terminal cash flow. This is the amount that is expected to be received at the end of the project's life. The project's life is 3 years. 1, 2, 3. 1, 2, 3 years. So this 5 million will be received at the end of year 1, which is the beginning of year 2. Which is the beginning of year 2. So it's going to be, the period is 1. Then this is, 1 should be here. Then from the start of year 2 to the beginning of year 3, that is 1 period. This is assuming it is January. Then end of year 3 at the end, because this is year 3 at the start. Year 3 starts here. Then after another year, it will end there, which is the start of year 4. So this cash flow is going to be compounded twice. That's why here we're going to have the 5 million raised to 1.1 raised to 2. How much is that? So the present value here is 5 million. One plus R. It is 1 plus 0.1. This rate converted into decimal. 10% candidates, 10% converted into decimal is equal to 10 over 100, which is equal to 0.1. So don't ask me where I got 0.1. This is where I got it. It is 5 million into 1 plus 0.1, which is equal to 1.1. Then I raised to 2. And don't ask me where I'm getting this 2. The 2, I'm getting it here. Do you understand up to that point? Is it clear up to that point? So we are getting the future value. This is a present, but these are money expected to be received at the end of these years. This 5 million will be received at the end of year 1. This 5 million will be received at the end of year 2. This 5 million will be received at the end of year 3. And because it will be received at the end of year 1, we are going to compound it using 2 periods. 1, 2. So how much is it? 60, 50. 60, 50. 60, 50. These are terminal values. 60, 50. We come to this cash flow that will be received at the end of year 2. 5 million will be received at the end of year 2. The cost of capital does not change, but the period has to change. At the end of year 2, we have period 1, period 2, period 3. So this 5 million was received at the end of year 1. This one is received at the end of year 2. At the end. At the end of year 2 is the beginning of year 3. Okay? It is the beginning of year 3. So assuming year 3 starts here, then after 12 months, which is the start of year 4, at the start 12 months, there is 1 period. So the money was received here at the start of year 3, then it ends at the end of year 3. So it is only 1 period. That's why here we raise it to 1. 5.5 million. Someone says 5.5 million. 5.5 million. So now we have this other cash flow that is received at the end of year 3. At the end of year 3 is the end of the project's life. So we're going to have 500, 1.1 at the end. We have year 1, year 2, then we have year 3. So this money is received when we've come to the end of the life of the project. So we are going to raise it to 0. 0. Any number raised to 0 is 1. And therefore the cash flow here remains to be 5 million. 5 million. So these are terminal values. And this here, this is the one where there is a trick candidate. As long as you get, how much is it? Someone says 16,550. 16,550. So this is 16,550. That is the total. Total what? Terminal value. You see here? That is already step number 2. These are the terminal values. These ones are the terminal values. Step number 1, terminal values. Step number 2, total terminal. That's the total terminal values. So the total terminal value is taken as a single cash flow of the project. So this is the single cash flow of the project. And then calculate the MIRR. Calculate the MIRR. So this is a future value. We've first of all compounded each cash flow using the appropriate compounding rate and the appropriate period for each cash flow Then we get the total terminal value, and this 16,550,000 is a terminal value. This is a future value which we have to discount. We have now to get the present value of this future value. We need to get the present value. We need to discount it. So candidates, observe this. We know that future value is equal to the present value 1 plus R. So we have the future value, which is 16,550. This is the terminal value, 16,550. Do you have the present value? Yes. Do you have it? What's the present value? Do you have the present value? The initial investment is 10 million. So we have the 10 million. One plus R, which is now MRR. We want to determine the MRR. Now, and that is a very important point, candidates. This point here, you have to understand that the MIRR, if you didn't understand this, then get this from here, because it's just the same thing, but I'm using different words. This MIRR, this one, which is the same as this one. The MIRR is the discounting rate at which the present value of the project cost is equal to the present value of the terminal value. And we've calculated the terminal value. We know it is the sum of the future values of the cash flows. The terminal value is the sum of the future values. These are future values of the cash flows. These are cash flows, these are the future values. So the terminal value is the sum, that's why we added. It is the sum of the future values of the cash flows. Terminal value is the sum of the future values of the cash flows. Please write it if you have to. I've gotten few words for the definition for terminal values. Terminal value, a terminal value in the context of MIRR, terminal value is the sum, which is this one, it is the sum of the future value. These are future values of the cash flows. So we calculated the future values of these cash flows, then we added them. That's why we are saying the sum, and we are calling this sum terminal value. So this is we are now going to calculate MIRR. We just make MRR the subject of this equation. And how do we do it? Divide 10 million on both sides. Divide 10 million on both sides. So this cancels out with that. How much is this? These are 4 zeros. 1, 2, 3, 4. This will be equal to 1.655. Am I right? Which is equal to 1 plus MIRR. So make MIRR the subject. This can be written as 1 plus MIRR is equal to 1.655. And therefore, we subtract 1 from both sides. So you have MIRR being equal to 1.655 minus 1. Subtracted 1 from both sides. So this will be equal to MIRR is equal to 0.655. And that, is that true? Is that accurate? I left power. Yes, I left the power. The power is 3. The power is 3. So there is a power of 3 here. There is a power of 3 here. Okay. That is so. The power. I was lost in explaining this. There is a power here. This is the general formula. So this is equal to that raised to that. So there is an n here, or t if you like. Okay? So at this point, if you are to make MRR the subject of this formula, we will get the third root. 1 plus MIRR, the third root on both sides. So you have 1.655 raised to that root. So give me this figure. 1.183. This is 1.183 is equal to 1 plus MIRR. So 1 plus MIRR is equal to 1.183. Subtract 1 from both sides. We have MIRR is equal to 1.183 minus 1, which is equal to 0.183. Convert this into percent. Is it? Convert this decimal into percentage, you multiply by 100. So this will be equal to 18.3%. We are taking the longer route because we are learning candidates. But if you are to use a formula I had written earlier on, remember this formula. MIRR should be equal to the nth root of the terminal value of initial investment minus 1. So if you are to apply this here, you will have the nth root, which is the third root. Future value here 16,550 divided by 10 million minus 1. Is it still the same as 18.3%? Alternatively, MIRR is equal to the nth root of the terminal value divided by initial investment minus 1. Yes, it's the same. Profitability index. So allow me to do away with this. So kindly you now understand that if you don't have to memorize the formula, you don't have to memorize, you just need to understand the procedure, the steps. Step number 1, calculate terminal values. Then you will equate these values here. This formula, we covered it in time value of money, compounding. Future value is equal to present value times this factor. This is compounding. This again, we covered it in 844 standard 7. Standard 7, look at the 844 standard 7 mathematics. The topic is money. This formula is also there. Compounding under interest. So you have no reason to say you are not understanding. If you are not understanding, it's because you don't want to understand. Because if you are appearing in this class, it means you passed your KCPE. That is, if you went through the 844 system, you went ahead, and we still teach this in secondary business studies. It means you also passed your KCPE, and again you are at it. Again, if you went through ATD, you covered it again in ATD. If you are holding a degree in, say, business degree, this must have been covered. So do practice compounding. And even if you've not gone through the courses I've mentioned, you must have invested money, which is compounding. And if you've not even invested money, it's not only money that is compounding. If you have a hen and it is laying eggs, it's still an investment. You can compound and get number of eggs in quantities. Okay, compounding. Increasing future value. To get future value, you take the present value, you apply this factor. So the amount you get here will be higher than what you had at the beginning. And if you are married, that means, and maybe before you got married, you didn't have children. If you have children, you see, it's the same principle, just increasing.